Hello, this is Dr. Oz. Today I would like to talk about how to generate an alternative optimal solution. So let's go back to the model that we developed for Foster generators transportation problem. In the problem, we were trying to decide how many units of product should I ship from origin nodes to destination nodes. And I had three origin nodes, one, two, three, and I had four destination nodes, namely one, two, three, four. And here we got the optimal cost of $39,500, which is minimization problem, minimize transportation costs. However, if you look at these decision variables, their values are zero. That means that there is no shipment between point 1 to point 3, point 1 to point 4, point 2 to point 2, etc. So, however, based on management decisions, or if you don't want to fire employees in certain region, or if you want to have presence in certain region, you may want to have more presence in those locations that you have zero shipments. In this case, if you look at it, um, uh, for example, facility 3 doesn't ship anything to facility 2, 3, or 4. Um, Another thing is facility 1 doesn't ship anything to 3 and 4. So this may not be the most balanced transportation problem, all right? So if that's the case, if you would like to find an alternative solution, you need to focus on these decision variables with zero values. In this case, I have 6 of them. And if I try to maximize these values uh, without having feasibility issue and without decreasing my optimal solution, basically that will create an alternative solution. So what do I mean by that? If you go to the next slide, so I would change my objective function from minimization to maximization, and I will try to maximize these 6 decision variables with the zero values. And then other constraints, these constraints are exactly the same, the 7 constraints that we developed. I'm not gonna change on them. However, I add a new constraint here, and this is making sure that when I add all these values up, I'm still getting the same objective, which is $39,500. Of course, I still have my decision variable. Decision variable should be greater than 0. All right. So if it's if you solve this problem, we can find an alternative solution. Again, this is not necessarily true for always, but in this problem, we can find an alternative solution. Excuse me. Now, here we see that start shipping 2,500 units from Bedford to Chicago. These values didn't change, and also we have some shipments now from. Actually, no, this didn't change. Basically, this is the only thing that changed. If that's what is important for my managers or contractors to ship products from Bedford to Chicago, it's an alternative solution that will give me the same results. So the steps are given here in the next slide. That you need to first solve the problem, of course, LP problem, and then define new objective function, which is maximize the decision variables with zero values. Make sure that all the constraints are the same, but add another constraint that the optimal function is not going to change, and then solve this problem. All right, so let me show you how to solve this problem on Excel. All right, so again, this was a solution for our Foster generators. We could minimize our cost by $39,500, and we need to ship these products from these locations to these locations. As you see, there are zero values here, and zero shipments here, and the constraints are here. So what I would like to do is I would like to keep my objective function previous objective function value, which is minimize cost, exactly the same. So what I would like to do is objective should be the same. Have same objective function value. So what is that? $39,500. Okay. But my new objective is maximize decision variables with 0 values. So this is my new objective. So I need to sum. I hold on to control, highlight these two, highlight these two, and highlight these two, release control, close your parentheses, and enter. I would like these values to be maximized. Currently, I have only 0. And I would like to add my new constraint here, which I want to make sure that I get the same objective value. Right-hand side value is given here 39,500, and it's an equality constraint because I want to make sure that I'm getting the same costs at the end of this model. And my left-hand side value is, again, sum product. It's a linear program, so coefficients, comma, decision variables. So if I rerun this model, data, solver, my new objective is not minimize cost, but maximize decision variables with 0 values. Enter. Decision variables didn't change. These 7 constraints are still there, but I would like to add another constraint, which I want to make sure that my result will be equal to $39,500. Click OK. If you solve this problem, all the constraints and optimality conditions are satisfied. Excellent. Click OK. I get still 39,500. Actually, wait a second. I don't think this worked because we did not choose maximization. So I still get a 0 here. I want to maximize this. Let's do it again. Data, solver. All right, my constraints are good. My decision variables are good. Simplex LP, check good. But I want to maximize my non-zero, my 0 values. Solve. And then click OK. As you see, I get exact same objective function value, but this time I start shipping products from Bedford to Chicago, and I maximize my decision variables with 0 values now. So my, again, objective function is the same. So by doing this, you can generate alternative solutions which can satisfy some managerial needs or some employee requirements and so on. That's it for this video. Until next video, enjoy business analytics.